Okay, we have here another integral from the UNSW Integration Bee. This one's from 2019. Problem 24. We have the integral from 0 to pi over 4, secant to the 5th x dx. The thing I noticed first is we have an odd power on the secant. Now, if we had an even power, we could start turning some of these into secant and look for a u substitution. It doesn't work as well with an odd power. So what I'm going to do instead is we're going to look at integration by parts, but I'm going to do first, we can split this out. Secant to the 5th x, I can write as secant cubed x times secant squared x. Now for integration by parts, I'm going to use the DI method or tabular integration. We'll create two columns. We're going to have a column to differentiate, well, a part to differentiate and a part to integrate. And I want to integrate secant squared because that's very easy to integrate. That's a known integral, so we'll use secant squared to integrate and we'll differentiate secant cubed. Okay, so then we'll get our derivative here on secant cubed. So we'll use first power rule and we'll have 3 secant squared x, and then chain rule. Derivative of secant is just secant x tan x. Yeah, it's taking up a lot of space. Here, what I'll do to squeeze this in, we have secant squared x times secant x. I'm just gonna make that into secant cubed and clean this up a little bit. Okay, and we'll do a quick integral on secant squared x, but that's just tangent x. Okay, so then what we have here on the diagonal, that's going to be part of our answer. So we'll just write that down first. We're going to have tan x secant cubed x. And then here, this whole part is going to be an integral. I'm just going to continue with it over here. So we're going to have this going to be minus 3 integral, but we'll multiply, okay, tan times tan, we're going to have a tan squared and secant cubed. But for tan squared, what I can do is I can convert that. We can use the identity tan squared plus 1 equals secant squared, or tan squared x is going to be the same thing as secant squared x minus 1. So what I'm going to do now is just rewrite this. We'll bring this piece down. And what I'm going to do is we're going to take this and we'll distribute in the secant cubed here. And I'm going to split this into two integrals. So we're going to have secant cubed times secant squared. We'll have an integral of secant to the 5th x dx. Noticing that's actually the same as our original integral here. And then for the next piece, we're going to have a minus secant cubed. But I have this minus 3 in front, so I'm going to distribute the minus sign. We're going to have a plus 3 integral secant cubed. And this is something that comes up a lot in integration by parts, where we get back our original integral and then we just have to solve for it. So what we'll do is to make it easy to solve for it, we'll say our original integral is I, then this is I, and then so again, this whole thing is I. Now, all I need to do to kind of solve for this, we'll just add a 3i here and add a 3i here. Okay, so then we're solving for 3 plus 1i is 4i. So this piece goes away and we're gonna bring down our tan x secant cubed, and then we'll just have this integral of secant cubed. Okay, so now we just need to find the integral for secant cubed. And if we did this out the long way, we'd actually do it the exact same way we did here. We'd do integration by parts and pull out a secant squared. But this is a pretty well-known integral, so I'm just going to use the formula and we won't do integration by parts again. And so the formula for that is going to be 1/2 secant x tan x plus 1/2 natural log secant x plus tan x. And then from here, all we want to do is we just want to get back to our I value, and we've got 4 copies of the integral now. So all we do here is we're just going to divide by 4 to get just 1 copy back. So this whole thing we'll divide by 4, and I'm out of space. We'll clean up the board and we'll clean this up. Okay, so now I've rewritten this, and you'll just notice I've divided through by our 4 that we were dividing the whole integral by, and that's how we got to 3/8, 1/4 here. And I put back in our bounds. We need to now evaluate this from 0 to pi over 4. I think I was kind of sloppy on the other board writing my bounds, but here we got them back. So you can see to do this evaluation, we're just going to need the value of secant at pi over 4 and 0 and tan at pi over 4 over 0. So let's see what those values are. Okay, so now evaluating this, so we'll start here and we'll have, this is going to be 1/4. Tan at pi over 4 is 1. Secant pi over 4 is square root of 2. Square root of 2 cubed is going to be 2 square root of 2. Then for this next term, again, our tan at pi over 4 is 1, so there's 3/8 times secant, which is square root of 2. Then we're going to have 3/8 natural log secant, we're going to have just square root of 2 plus 1. I can actually drop the absolute value because that's clearly square root of 2 plus 1 is clearly positive. And then next, evaluating at 0, we get some good cleanup, good simplification here, because when we plug tan at 0 is actually 0. So this term is going to 0, and this term is going to 0 as we're multiplying by 0. And we just need to deal with this last piece. So we have 3/8 natural log secant at 0 is 1, tan at 0 is 0. So that means we're taking natural log at 1, but that's 0, and so that piece just goes away, all this right here. Okay, so all we need to do left now is just a little simplification. Here we have 2/4. I'm going to just take that and we're going to rewrite that as 4/8. I mean, it's 1/2, but I want to combine with this. So then combining these two terms, 4/8 and 3/8, is going to be 7/8 square root of 2. And then here we're just going to have, this is going to be as it is, 3/8 natural log square root of 2 plus 1. Okay, that's it. Just integration by parts with quite a few steps. So we'll stop it there. Thanks everyone for watching. Have a great day.